All right, everybody. Hello and welcome back to Databases Deep Dive with Nick and Randall. Today we're joined by a special guest, Anoop Gupta, who's the Senior Software Development Manager over for Amazon Aurora Postgres.
MySQL.
Sorry, MySQL.
That's it.
So today we're going to be talking about serverless databases and RDS Data API and a lot of cool stuff around that. And maybe we can just launch right into it.
Sure. I helped launch Aurora Serverless last year around August. What we did is I'm going to go through kind of RDS and Aurora fundamentals, kind of level set a little bit, make sure everyone kind of is on the same page. I'll go through that really quick because I want to focus on the serverless side of things. And then I'm going to go into what Aurora Serverless is and then how it works. And then we'll have a bunch of time for questions and answers. So Amazon RDS. The idea is Amazon RDS has like a couple different things we do. Well, more than a couple, but the idea is we have we take open source and commercial engines, and we've done this for a number of years, and we package them, and we add a lot of like management functionality that we have in the RDS platform. This worked great for a number of years, but then we started having customers that had limits. They started hitting these hard limits on either commercial engines or on open source engines. So what we decided to do is we decided to go and create Amazon Aurora, and Amazon Aurora was the answer to that. It was basically to take a look at, on the commercial side, the pricing issues that the customers were hitting, and on the open source side, some of the scale limits that customers were hitting with the cloud.
And so people who have been watching the series know that last week we actually spoke with Yuri, where we talked about decoupling the scaling of storage and compute. So we talked about broadly in episode 5, like Aurora being the sort of database built for the cloud, right? But we're going to hear a little bit more about how Postgres comes in here and, right? Or no? Sorry. MySQL. Sorry. Go right ahead.
So the serverless stuff actually applies to both MySQL and serverless. So
Yes.
or MySQL and Postgres. So
Right.
it's not that it's one or the other. I'll talk about Postgres is in preview right now. MySQL we've already launched.
Okay.
So from an Amazon Aurora perspective, we basically made it much more available, higher durability. You can talk. Yuri's talk is probably will get you into a lot more depth there. I'll just keep going. Generally speaking, it was a kind of a move to eliminate a lot of these bottlenecks that customers were having.
It's about reducing I/O. Like that was so I've read through every single one of the Aurora papers. I see them somewhat as Bibles, and there's this weirdness that happens in the first two papers. They describe this beautiful architecture of the separation of compute and the isolation and sending over redo logs and sending over like pages and stuff as part of the storage layer, and basically minimizing write amplification. And then they go and they pull this amazing hoodwink on us in the most recent paper, where they say, hey, we said that you only need a quorum of 3 for writes or for reads, and you need a quorum of 4 for writes. But it turns out you don't really wait on anything. If you get the chance, go and read the Aurora papers. They're very, very interesting, and it really is a deep dive into how you reason about machines and architectures in 2019.
Yeah. It's like reducing locking. There's a bunch of stuff that they go into there, like that. It's all about that throughput, and like without all the work they did, there's no way we'd be where we are now. So I'll just kind of keep going past. So Aurora was great. It kind of allowed us to scale out and did all this stuff. But the issue that we still had, and we kind of discovered over time, was that customers still had to size their load for peak, or they had to constantly monitor things and scale up or scale down. Neither one of these is great. Either it's inefficient or like it's a lot of work on your part as a customer. So what we did is we said, well, it'd be great if we had a serverless database. Well, the first thing we had to do was figure out what does a serverless database mean. So serverless has a few things that kind of come along with it. Making sure that like you basically only pay for what you use. It basically is only operating while you're using it. It scales to your capacity level. And so we basically said, well, it has to handle startup, shutdown, and scaling. Like those are the 3 things we had to handle from a technical perspective. And then there was some other stuff on the billing side that we had to deal with as well. So we looked at like some real world examples, and we said, okay, looking at these real world examples, these are actual customer workloads. We have dev test workloads, we have idle workloads, we have like gaming workloads. There's like reporting things. a lot of customers just don't use their databases to their full load all the time. And they do provision for the peak in order to make this work. So you have a choice, provision for the peak or provision for less than the peak, and then your end users are getting throttled or they're having some kind of impact. You can provision for the peak, which is more expensive, or you can basically scale up or scale down. And this is hard because it either requires downtime or a lot of extra work on your end.
And I'll provide some context here. Before Aurora Serverless existed and before a lot of the cloud existed, the way that we would do this scaling up and scaling down is you would essentially take a Fourier transform of the time period over which you needed to scale, and you would extract out the periodic elements, and you would say, okay, these are my peaks, so I know I'm going to need more capacity during that time. And the unfortunate thing is that math alone does not capture the real issue.
So the FFT, the fast Fourier transform, essentially what that's going to do is it's going to extract the trends that exist in your existing data, but that in no way actually is predictive for going forward or for saying, all right, here's new data. Can you predict this behavior that did not already exist in my data?
It becomes a forecasting problem.
Exactly.
Yeah.
And you mentioned this with databases, but this is in no way unique to databases. This problem, like compute faces this, and any other resource that you need to think about scaling faces this over, under, or scaling provisioning problem.
Yeah. DynamoDB launched predictive autoscaling a little while back, and that's exactly what they do. But either you have to do it yourself, which is possible, or we can do it for you. So one way customers also did this without downtime was to actually add some kind of a proxy. Like in general, customers could basically manage their capacity, add a scale up target, move things over, and do a cutover, but they would take downtime. And the other downside is you'd have this new instance that was sitting there with your database, but it'd be cold, right? So your memory would be cold, so your queries and your SQL statements wouldn't be as responsive as you'd expect them to be.
The RAM wouldn't be hydrated, all these other things.
Yeah. Instead, there's some proxy solutions out there on the market today. You could add your own proxy, and you could shield your connection from shield your application from the connection changes. Do the cutover. You don't have any downtime. The only issue is now you have a single point of failure, and you still have that cold buffer pool. So neither one of these were great. So we decided to say, let's go create Aurora Serverless. So the idea was to address these main issues. So we would scale capacity with no downtime. It was a multi-tenant proxy in place, so that way it would always be highly available. If one instance in that proxy went down, only a subset of connections went down. We would warm the buffer pool, so that way you were always dealing with a warm instance, and then it actually would shut down or pause when it's not in use.
So when you say shut down or pause when not in use, how does that behavior work in terms of going from shut down to running?
So right now we have a bit of time that it takes to wake up or restore. The idea is it takes about 30 seconds today on average to restore a cluster from pause all the way to like a ready state. A customer basically talks to the same endpoint they would normally talk to. They talk to our proxy, and our proxy then goes and talks to our control plane, and our control plane then goes and takes an instance from what we have what's called a warm pool, brings that instance in, connects it to your volume, gets the database up and running as quickly as we can, and then you're operating.
And what we learned from Yuri is that those instances, they're not just pulling in the data pointers, they're pulling in the pages and everything, so they can be ready to go right away. Because they're basically dealing with 10 gigabyte chunks, and if you have a 10 gigabit per second connection, you can pull that in 1 per second, and then you can multiplex that, you can multi-thread that.
Yeah. And so when people think like spin down to 0, they think like, okay, well, does it just get deleted? Like what exactly happens? So the proxy remains persistent, and that enables you to still, or AWS, the service that's working under the hood, will help manage pulling in all those underlying volumes and connecting them to the instances.
Yeah. So the idea is like you have that same endpoint you're always talking to. You don't, as a customer of an Aurora Serverless database, it's invisible to you that this thing is going down. The only visibility is that it does take like 30 seconds to go from a paused state to a restored state.
Awesome.
So this is kind of more details on how it works. So here's basically you have the multi-tenant proxy. You basically have the warm pool of instances. We have our monitoring services, which is part of our control plane. And your application is talking through the proxy. And you can have multiple connections going through multiple pieces of the proxy. And this is instead of a restore, this is going to show more of a seamless scale. And what happens with a seamless scale is you hit some CPU utilization or max connection threshold or some other thresholds that we kind of control on our end. We basically get a server from the warm pool, transfer the buffer pool by like reading from the shared storage, and then we look for a safe scaling point, and then we basically transition your connections to the new instance. The idea is it's completely seamless. As a customer, you don't have to deal with anything. It's as if nothing happened. There is a small blip where the latency goes up. It's sub 1 second. So the idea it's a very like seamless transition.
So how do you find one of those scaling points? That seems like it'll be hard to dial into, especially with multiple transactions and things like that going on.
So today there are two limitations on finding that scaling point. One is a long running transaction, and the other is temporary tables.
Well, long running transactions are a really bad practice anyway. So it's not like that's I don't think anyone overcomes that in any of the software that they build. Just don't do it. But the other one was
temporary tables.
These like views or like temp views?
Temp views, yeah.
Okay.
Yeah, the idea is it's something that's stored on that instance itself. These are things we're looking to like get rid of in our longer term roadmap in terms of like make these not blockers to seamless scaling. But the idea is they are there today. The other option that we do have on the table is we added this post GA was to force the scale, which would drop your connections. But for some customers that they really they want to make sure they have the capacity.
And a lot of the ODBC, the JODBC drivers and those other MySQL and Postgres drivers, they support retries on these connections. So they're used to these kind of, not necessarily flapping, but a transition or a cutover, like a secondary gets promoted to a master or something like that. And so they know how to deal with it without you having to write the retry logic yourself.
Yeah, I mean, in general, you have to deal with the fact that a connection could drop at any time because, this is just like any system. They could go down or there's some issues with it, like where your connection might get dropped. Failovers are an example. And as a result, you have to be resilient to some level of failure. The force scaling is a little bit more regular if you're scaling a lot, but the idea is that it shouldn't be it shouldn't be much of an issue depending on your application.
And last week when we were at Remarch, we spoke with Yuri, and he was talking about the LSNs. And do those play any part in choosing a scaling point?
So the LSN doesn't play a part in this finding a scaling point. What we do is we talk to the underlying MySQL engine. We basically made changes there where we look for a safe point where we can hold the connect. We find like a point where there's no long running transactions, no temporary tables going on. We hold those connections up on that instance. We communicate back to the proxy and say, hey, hold any new transactions on the proxy, and then we transition those anything new that may have leaked through basically because of timing issues to the new instance.
And then are we going to write a paper about that? because sorry, you described it very simply, but that's an incredibly complex operation.
Yeah. It's basically in place vertical scaling of a relational database. It's definitely innovative, and like that's one of the best parts of my job. I love the fact that we kind of get to innovate in this way.
Going back to the LSNs that we spoke about with Yuri, it really felt like those were sort of just like magical in the way that they are leveraged and can have you can revert back to different points in time with them. Yep. So with regards to restoring a database here, how does the LSN play a role there? Is that the record that is hit with respect to that, or where is that living?
The LSN is more of a storage concept. This is more on the compute side, right?
Okay.
So the idea is like we're going up against an active volume. It has nothing to do with restore. The volume is still active. We're just doing basically what amounts from the underlying storage perspective as a failover from a writer to another reader.
The compute scale is independent entirely of the storage. Yeah. That tier keeps operating at the same thing, and you're basically propagating some message up to that proxy tier that says, yo, we can cut over now if you really need to, otherwise keep going.
Yeah, I'm the active instance that you should be talking to. That's basically what our control plane does. And it says, that I should be talking to this instance now, and then I can cut over to this new one. And you don't have to deal with any DNS propagation times or anything like that, because we do this all under the covers with other technology.
That's really cool.
Yeah. So you got the best part about this is you have a warm buffer pool, and the workload just kind of resumes. This is kind of the scale down to 0 case. The idea here is that when the workload goes idle and there's no connections to the actual like proxy, we basically scale the instance down to 0. And then when we get a new connection coming in on the proxy, we spin up the instance.
So, couple questions here. Is it possible for me to take a snapshot of a regular Aurora Postgres or Aurora MySQL and restore into Aurora Serverless?
That's basically the only way to migrate to Aurora Serverless today.
Okay, so is there any reason my dev workload should not be running on Aurora Serverless?
If you had if you wanted to work on a specific version of Aurora MySQL, then yes, you would want to go
into that version.
Into that version. Right now, Aurora Serverless, because of the warm pool, we only have one minor version per major version.
Okay.
And
it makes sense because you don't have to maintain 3 different fleets of warm pools and stuff.
Yeah, it's basically a financial thing.
Okay. It makes perfect sense. I am immediately after this going to go switch all of my RDS instances over to Aurora Serverless.
I mean, from a dev test perspective, like customers save a lot of money because often you have a dev that sits around and does something for an hour and then leaves that database up and running forever. And in this case, it just goes to sleep automatically, and you don't have to worry about it. You only paid for what you use. It's a perfect use case for dev test.
So on the topic of pricing, we have a great question from the chat from Gorano Pasik. With this pricing, what is the real-world scenario that makes serverless database a better solution than some RI reserve instances?
So it depends on your workload. It's highly dependent on your workload. If you have a spiky workload where your capacity scales up and down quite a bit, that's definitely one case. If you just have a periodic workload that you can basically say, hey, on Monday morning at 9 a.m. I need capacity for an hour. It's also those types of use cases are really good. Or dev test where you're using it for only 5-6 hours a day or even 2 hours a day. Basically, you pay by the minute and you pay for what you use, and it automatically pauses.
And the scenario that I know is actually very common as well is where you have a cyclical pattern, but your bottom out is not 0.
Yep.
Like your minimum may be some minimum threshold. And so the recommendation I've seen in the past is where you take reserve instances to meet that minimum because they'll be utilized entirely. And then you could use the serverless implementation to handle all that scaling above that minimum.
Yeah. So you can't mix serverless and not provision today. So that's the only downside there.
Not yet.
Yeah, not yet.
Not yet.
Well, no, I
commonly I've seen that for compute, and obviously you can shift things around to make that possible.
Yeah,
but
so I think it's a little that's with EC2 reserved instances it's a pricing thing.
Yeah.
So it does.
The other thing is the Spot Fleet API or just the regular Fleet API for EC2 now lets you mix and match all those pricing models. But I see serverless as kind of separate from all of that. Actually, I mean, I'm not a thought leader. So if you go on LinkedIn, I have a real title, and I'm not thought leader. Or what is the other one? Business development or
fire emojis.
Yeah.
Or Bitcoin.
I find serverless to be a different paradigm entirely from the way we've previously thought about our data tier, and I think it's really, really powerful because it opens us up to being able to have a specific data tier dedicated to a specific microservice as opposed to one monolithic, absurd data store that we have to fight over time for.
Yeah, I was just talking to a customer this morning that's looking at transitioning over, and one of their big reasons why is to get that isolation at a per use case level. And it's great because then they insulate, they don't have this noisy neighbor problem of one application basically affecting another application on the same data tier.
Yeah, we talk about breaking up the monolith with respect to your compute and your application architecture, but now is it coming finally to the database? Is that what we're gonna arrive at soon?
That's where
Oh, well, okay.
That's what we're doing today.
Spoiler alert.
Yeah. That separation is a great way of doing it. You can go in two directions there, I should say. Mm-hmm. Some people will separate. Some people will actually combine. We've seen actually customers say, well, since this automatically scales for me, I can combine a bunch of workloads onto a single underlying data tier, and I'm not worried about the noisy neighbor problem, so it's just going to scale for my use case anyway, so I'm going to allow it to scale rather than having to separate.
That's pretty cool.
Yeah.
All right. Sorry for the sidetracking.
No problem. It's more fun that way. So basically, we talked about this earlier. When one of the proxies instances goes down, only a fraction of the connections go down. So the idea is that proxy is meant to be resilient and highly available. And it's the idea is like that only a fraction of your connections go down, like any other multi-tenant fleet or service that Amazon runs. So the end result was that we really wanted to make this a much simpler experience to customers. You didn't have to monitor CPU credits. You didn't have to worry about availability zones. You didn't have to worry about migrations or instance types. It was all, like encryption was on by default. No DNS issues. Like the idea was that as a customer of Aurora Serverless, like all the things that you have to deal with from an infrastructure perspective were things that you just didn't have to deal with anymore. And that was our goal. And so far, we've been pretty proud about what we've actually come up with, and our customers seem to really like what we've gotten out with. But with any new service, there's feedback.
Yeah, definitely. Good and bad, I assume.
Yep.
But you learn from the bad and you appreciate the good, right?
Yep.
So you say this is a random question. I maybe the stream isn't the best place to ask this, but is there an integration with the service discovery service on the Route 53 side right now for this, or do you just need to point it at the endpoint and then
you just point it. Okay. You point it to an endpoint. The idea is what we do is when we create an Aurora Serverless database, we create 2 VPC endpoints in your VPC, so that and a regional DNS, and then you talk to that regional DNS, gotcha. And then you've got you can talk to it.
So we've got one point of clarification asking from the chat from TBE all. So this is a point of clarification, but they're caught up on semantics between hosting RDS with Postgres versus Aurora with Postgres because they're confused because isn't Aurora part of RDS? Like, how does that relationship work?
So I work on both RDS as well as as well as Aurora, and the teams are very much joint teams. So like when you're talking to from the service team perspective, we're the same team under the covers. It's not like it's one team versus the other.
It's Scooby Doo. You pull the mask off the villain, and it's just Anoop in both.
As the idea is, it's about choice. Like we want to provide customers with choice. RDS is basically taking the existing MySQL, Postgres, SQL Server, Oracle, or MariaDB engines and like taking the exact copy of the open source or commercial database and then putting them and hosting them for you and making that moving from a self-managed to a more managed solution. Aurora is that next step for customers that are hitting some of these issues or want a more managed solution. Like we don't make changes to the engines for any of these or any of the RDS solutions that we have. So if you have an issue, like we basically point you to the provider of that software on the engine side. If it's a control plane side, obviously we handle that. But with Aurora, like we actually will take and we will solve the underlying engine issues.
So RDS is an overarching service, relational database service. You have different engines: MariaDB, Oracle, MySQL, Microsoft SQL, Postgres. Mm-hmm. Then you have Aurora as an engine under RDS, and that supports a couple of different invocation types. So
it's wire compatible with MySQL and Postgres.
Okay, and then the engine is just its own custom, as we've written about in a couple papers and blog posts. Now it's like a whole big thing and reimagining of the database and as a cloud native kind of solution. And then Aurora Serverless is going one level of abstraction beyond that and saying, hey, you don't need compute instances, we'll manage that for you.
Exactly. And we even do that from the pricing perspective. We don't even call it instances. You get something called ACUs or Aurora capacity units. And that is to basically insulate you from the fact that there's an underlying instance there. And as we upgrade instance types, you just get the better performance, right? It's not that like we're having to do a whole lot of work and having to work with you to migrate it and do all that. Because you're not talking to that underlying instance, we can upgrade the underlying instance and give you better performance without having to worry about anything.
So we have a couple of questions from the stream as well about and some of these we might want to pause and get to them later because I know you might have some more content. But one is about, can we talk to Aurora from Lambda? I think you've got a pretty interesting thing to talk about there. And then that was from Thulaban. And then we had another joke, we had another question from Bill Go Jake about what algorithm do we use regarding DB stopping or pausing, and is it configurable?
Yeah, so I'll address the DB pausing stopping one because we were just talking about that.
Right.
So for DB pausing and stopping, today what we do is we say if there are no connections to the database, we basically say we pause it. It's a very basic algorithm.
Is it like 5 minutes of no connections, or is it?
Is as soon as we see no connections, basically like we go to pause. There is a bit of time
Jitter and back off and all that good stuff.
But yeah, we basically pause it as soon as we see no connections. The idea is that as soon as we see no connections, it should be an indicator that like there's no load.
And given that, like, obviously the start from 0 to the first connection shouldn't be too long, right? Like, if that was longer than it currently would, maybe we would change that, right?
Yeah, there is a back off, and there's a bit of a back off, and it's customer configurable as well.
Oh, okay.
What the back off is.
Great.
It's just like it can be driven all the way down to something very small or for something very large. Okay, so we can talk about the Lambda use case as well. Or we can go.
One other question from Bill
Sure.
Gojake, kind of aligning to what we were just talking about with Aurora capacity units. How do those align to an instance size?
So under the covers, we map them to various instance sizes. It can go anywhere from a T2 small to an R4 16XL. It varies depending on how many ACUs you're actually at that moment in time. We may change that in the future. The idea is we'll basically provide you that amount of capacity to do that workload.
And does an ACU correspond to any particular amount of throughput or anything like that, or is it a general scaling?
It's a general scaling. The hard part with throughput is it's workload dependent again.
Yeah.
So it's really hard to say like, okay, will your throughput be the same as what we're measuring on
Right.
some kind of like test.
So ultimately, it's your mileage may vary, and running your own workload through it will be the best way to figure out what the capacity units look like for your throughput.
Yeah, and the nice part is you shouldn't have to worry too much about it because we will scale up and scale down for you.
Exactly.
So it's not like you have to test your workload against that specific instance and like make sure to test it at different loads. You can basically test it and then try different loads to make sure the scaling works for you.
Alrighty. So maybe we could talk about how we could answer Thulaban's question about how you can access Aurora from Lambda.
Sure. So there's two options. The first option is to actually talk to it just like you would any other database under the covers. You have a VPC endpoint which allows you to talk to it within your VPC. You can you do have to communicate through the VPC, which means you have to set up the VPC, which is possible through a Lambda, but it's not. It does require overhead. You have to set up the connection, and you can use a normal JDBC driver. That's one path forward. The other path forward is we launched the RDS Data API. It went into preview late last year, and we recently went GA. The idea behind the RDS Data API was to handle things like the Lambda and AppSync use cases. It's a web service that's on a public endpoint. You get to enable it or disable it for your Aurora Serverless database. And you can basically route SQL statements through a secure HTTP endpoint. And the idea there is that now you can do things from your Lambda without having to set up the VPC endpoint. It actually does things like connection pooling under the covers, so you don't pay that upfront connection penalty on a cold start or on a warm connection. On a cold start, you still pay somewhat of a penalty, but the idea is that
You do that TLS negotiation, all the good stuff.
yeah, all the TLS negotiation.
TCP.
And so does that data API keep like connections warm to the database in the meantime to make sure that that's...
It does for a period of time, right?
Yeah.
So it will eventually similar to how we pause on the serverless side, it will basically pause those connections or basically like garbage collect them away eventually. So if you're not constantly keeping them warm, it will eventually like take that connection pool away.
Story time?
Yep.
Story time.
When Lambda first came out, it only supported Node, and we had something that needed to talk to RDS. So I spun up a fleet, and this was not at Amazon. This was at another company that won't be named. We spun up a fleet of basically PG bounce servers, and we had, and that's a Postgres kind of connection pooling tool, and that kept falling over. So instead, we did Nginx reverse proxies that would basically take an HTTP connection, send it off to some Python code, or maybe it was Java code, I don't remember at this point, translate the HTTP request into something that could go and talk to the database, because when we put Lambda in our application tier, all of a sudden we had thousands upon thousands of connections, and all our ulimits on our instances were dying. So this would have saved me a lot of effort 5 years ago.
Yeah. I mean, that's exactly why we wrote it, right? Basically, like, we had all these customers that came and were like, you have a serverless database. How do I connect it with my serverless compute? And we didn't have a great answer for them at the time. So, like, we went back and we said, well, we should work on this. And the connection pooling is key to that. Is, you know, with Lambda, you might spin up like 10,000 Lambdas all going at your database at the same time, and your database at max can like support maybe 6,000, 10,000 connections. So you might basically make your database fall over as a result.
Yeah, I think, what did we get to? We got to 96,000 connections at one point, and it was completely unusable.
Yeah.
It was just throttling between doing the I/O on the first initial communication request, and it was unusable after that.
So we have some questions from chat, unless
Sure.
you want to.
No, go for it.
Yeah, so
Chat's better.
this is what we're here for. This is database office hours, right?
Yeah.
So people love getting to have their questions answered. So from Muse Invited, they ask, I'd really like to hear more about configuring Aurora Serverless in a CloudFormation template. It's really hard to figure out what resources are required if you try to do this. And if you're going to use it with Lambda, you either need the data API or a VPC. So they'd love to hear about what CloudFormation resources are required in either of these cases.
So CloudFormation support is in place for Aurora Serverless. It's basically like setting up any other Aurora database. You just pick a different engine type.
Okay.
So we do have CloudFormation support there. I have to look at data API and see whether or not we have CloudFormation support there. In general, it's you can actually enable it through the CLI. It's just it's a flag to enable for data API.
Okay, and so that can all be enumerated right in the CloudFormation template then?
It could be, yes.
Yeah,
Okay.
just change the engine mode to serverless.
Yep.
I wrote a blog post about this back when RDS Data API first came out, and I built a custom resource for spinning one up. So I'm trying to find that on GitHub right now, and then I'll post it in chat.
We've got a few other questions, actually. Lots of really awesome questions in chat. Condimenting asks, will Aurora be coming to the free tier? Is there a free tier for Aurora?
I don't know. That's probably a better question for some other people that's not as on the tech side.
Yeah, stay tuned to the what's next videos we post. Maybe it'll be coming to the free tier sometime in the future. We've also got, are there plans to support direct command line access with RDS
I
instances?
think you can, right?
Yeah.
Yeah.
So you can already do that today. There's two options. One is through a public endpoint for standard RDS instances, or the other option is to actually go and set up the VPC in your Lambda.
Awesome. And then I think one last question before we get back to your presentation. How can we replicate the data between on-cloud and on-prem DB for support? That's a very broad and generalizable question.
DMS does a little bit of that, but
Yeah.
it's not continuous replication.
So there's bin log replication for MySQL. There's bin log replication. There's physical replication for Postgres. It just depends on which engine you're using. There are ways of doing it. It's a pretty broad topic area.
Yeah.
DMS support is one way. You can basically do a migration with DMS. You can do bin log replication with MySQL, and then there's a logical replication with Postgres.
So
We're actually gonna, just on that last point there, we'll probably talk more about that in our DMS episode later in the season.
I was
right?
just gonna, so on Umai Rival One's question, which was about that, if you're doing it for DR purposes and you have that asynchronous replication happening, that's really not a big overhead. But I think doing replication between on-prem and cloud as a synchronous thing where you're buffering writes on that sort of stuff, no, I would never do that. It's a
Latency will kill you.
Yeah, it's way too expensive and it slows everything down. So it's much better to kind of keep it as like a DR scenario if you really need to. But you also have to keep in mind that with Aurora, your snapshots are backed up to S3, which has 11 nines of durability, and then however many insane number of, what is it, 6 different
copies across 3 AZs.
Yeah, and I to my knowledge, we've never had a single AZ outage, but having a whole region outage would be equally unheard of, and have it replicated in 6, so 2 different copies per AZ, essentially.
Yeah.
That's
the intention. Like, it's meant to be like highly durable and highly resilient to failure.
I mean, I'm not worried, but all I do is selfies, so.
I think we have one last question.
Sure,
Sorry,
no
I
problem.
lied last time. We have this awesome people in the chat today. So Thulban asks, is there a risk of using the first approach to talk to Aurora from Lambda with the JDBC driver? And are there limitations to the second approach with the data API?
So the risks of using the JDBC driver is that you don't have that connection pooling logic in place. So you could like overload your database with a number of incoming connections. That's probably your biggest risk in terms of using JDBC directly. There are some proxy solutions in place today that will actually do connection pooling. PG Bouncer was one of them. So you could take one of those existing proxy solutions that do connection pooling and put that in front. With data API, there are some limits on the maximum number of the maximum TPS. I don't have those numbers up in front of me right now, or I don't have them in my memory.
I also don't know them because one of the benefits of working at AWS is that I don't pay my AWS bill anymore. Probably, honestly, one of the reasons I will never leave is that I'm afraid to see what my bill actually is.
Randall doesn't remember things anymore. He just puts them all into S3, and so that's the highly durable brain he wishes he had.
A few hundred terabytes of data that's in there. All selfies.
All selfies. It's all selfies. All right, so maybe we can keep going here, and then
Sure.
we'll have some more questions coming in.
Yeah. The intention of these slides is more to like spawn questions than anything
Yeah.
else. So the data API performance, it's basically JSON-based responses, name parameters with transaction support. The idea is like we can do transactions over the data API. There's connection pooling that we talked about earlier, and then the APIs include an execute statement, batch execute statement, begin transaction, commit transaction, and rollback transaction. Basically, the idea is that we started off with just an execute statement, and we got feedback that multi-statement didn't work well, and that it had some issues with it, and then so we kind of went down the path of this batch execute, and actually the fact that we needed transaction support as well was feedback we got in the preview. So we've released all that today.
So with the JSON-based responses, have you had any requests from customers so far? Because I'm about to make one as a customer. For maybe a protobuf format or something a little more compact for larger responses?
We have had requests for like compressing our responses to make them more efficient in terms of sizing. We've actually done quite a bit of work since our preview till GA. We've done quite a bit of work to actually reduce the response size.
Does it do like pagination or anything?
It does do pagination.
Oh, okay. Yeah. And do we have on our side talking to that endpoint? Do we have to write our own pagination code, or is it included in the SDKs already?
So the SDK gives you back a token, and then you basically go back and you respond with that token.
Generally in our APIs, and I'll be honest, I haven't tried the new one yet, so I should know more. Like this Boto 3 slide that you're showing. Mm-hmm. So one of the advantages of Boto 3 is that you can spin up a paginator, and it's built into Boto 3. So you just go boto3.paginator, and then you say the API call that you're making, or you can even create one from this client.paginator, and it'll do it. And then for a lot of the resources, so boto3.resource instead of boto3.client, so you do boto3.resource RDS data. And I don't think this is actually implemented yet, but I'll get bored on the plane ride home, and we'll see what happens. That'll do the pagination for you automatically.
Yeah. I haven't tested that out. I'd have to try it out, actually. It's worth trying.
Yeah, I'll do that while we're waiting for chat. So, this is really cool. So this is the command line over here.
Yeah, that's the CLI on the left. Or depending on how you're looking at the right, I don't know exactly which way it's going.
I think it's on
still
the left.
Yeah.
Okay. And then on the right is basically some Python code that actually shows you how to use it in Python. So
and it looks like this is automatically pulling in the credentials from Secrets Manager.
Yeah, so a data API supports Secrets Manager as a way of doing auth. And the idea is that you basically provide the ARN for your secret, and then we basically pull the secret out, and then that's how you get your auth to the back end.
Yeah, so if you guys have never seen Secrets Manager before, the way that this works is it is a secure set of credentials that can be namespaced and managed by us and encrypted with your own keys or with our own keys, whatever key you want to use. And then you have mechanisms for rotating those. And I assume RDS rotates them automatically and everything.
There are some that's something that we're looking at. But the idea is that with Secrets Manager, you don't have to have that. You don't have to deal with the credential management in your your Lambda code, for example.
Yeah.
That's a big pain point for a lot of customers.
So much like having the persistent endpoint that you can query and then it'll spin up from zero. It's the same thing with secrets, where you just have the same ARN and it handles the rotation under the hood there.
And I mean, we used to do this using something called Parameter Store back before Secrets Manager launched. But Parameter Store didn't support any of that rotation, and it also didn't support the KMS side of things. And you also had a somewhat convoluted namespacing to deal with for secrets versus regular parameters. So the separation of concerns now that exists between Secrets Manager and Parameter Store is really good. And the other thing that I like is I didn't actually have to change any of my code because you can just call directly through SSM into Secrets Manager, and it's a transparent call through. Which I don't know who did that at Amazon, but thanks. That was a really good idea. Shout into the void.
Yeah, it is nice functionality to have, and it's like you said, it's tailor made for the solution, right?
Yeah, this is great. I mean, this is really if you think about the serverless vision, this is part of it. Is hey, I don't want to have to manage any state. I want to push as much of this as possible. All of this undifferentiated heavy lifting, which we use the phrase all the time, and I'm sorry, but it's just accurate. All that undifferentiated heavy lifting of secrets management, environment variable management, and pulling out the right kind of AMIs and the right kind of expanding storage. We don't have to do that anymore. Yep. We don't have to resize 2FS a million times. It's just 10 gigabyte chunks, and we grow. Mm-hmm. And then
basically the floor is getting eaten. That's why I was trying to think about it. Is we basically took away the base infrastructure, and now we're basically working our way up the stack and making it easier and easier to do all these things that were all this heavy lifting that you had to do in the past.
And then there's so I see as we're going down this code here. So we're saying import Boto3 client, Boto3 client RDS data. Mm-hmm. That's great. Client execute statement. It's going to load in the credentials from Secrets Manager. It's going to query database users, and it's going to have the ARN of the ARN is Amazon resource number. The ARN is going to be the stack or the cluster we spun up as Aurora Serverless, and then does this RDS data API support regular RDS as well?
Not yet. Today it only supports Aurora Serverless and Aurora Serverless for MySQL specifically.
Yeah. I mean, this is fantastic. And then you say for user and their response records, and you can go through them all. Mm-hmm. And if you need to do the pagination, I'm sure as part of most of these APIs, we always add the pagination in. So I'd be willing to bet it's there.
Yeah, I haven't tried it. That's why I'm not going to guarantee it because I haven't tried it yet.
Okay, so what if I'm not a Python coder and I'm not a JavaScript coder and I don't want to have to go down into my CLI and I just want to run some queries? Let's say I'm data scientist. Yeah. Okay.
So as a part of this, we were able to connect the actual console query, the console to your database. So the idea is now we have a query editor that's built into the console, and so you don't have to install anything. You don't have to set up VPCs. You don't have to set up any of the connections that you would normally have to set up. You basically go in and you go to the console, and you can start sending queries to your database.
That is okay. So did RDS do this first, or did Redshift do this first? Because I don't remember, but this is really cool.
Yeah, I think Redshift may have gotten there before RDS did.
Well, I'm glad that you pulled this in from there, because that was one of my favorite features when it first came out, and it's good to see this because I love the idea. Oh, hey, I have a quick thought. Let me just gauge it. Let me see how many records there are.
Yep, it's like Postman kind of, but for database querying in a way.
Yeah, and basically you'd often use things on your actual personal laptop, but with VPCs and it got really hard to do that kind of connectivity. So you ended up having to go to a dev desktop or a Cloud9 setup, and you'd have to spin something up, go on that. This just made it really easy to do these quick queries.
Nice. I know we're beating you up here with questions. I'm sorry.
No, it's fine. That's why I'm here.
I think the next slide might be my favorite of all time.
So Aurora Serverless for Postgres. So it's in preview today, and you can sign up and try it out. We are actively working on this, and it's something that is in the pipe.
You may not know this. I'm actually the biggest fan of Postgres. I'm such a nerd about Postgres. If you ever wanted to look through some of the most beautiful code in the world, go look at some of the implementations for common algorithms like R trees and B trees and things like that in Postgres. They're just really succinct. It's a great lesson in C. And I'm going to stop nerding out.
No. Well, I know, Randall, you used to teach a lot about database in the past prior to this show,
Yeah,
right?
I taught a database history class, but Postgres it's got one of the funniest histories. We don't need to get into it. We can.
We've got some time. I mean, I think we have some time. How long? How exciting is the history?
It involves Oracle taking out attack ads and about so Oracle takes out these attack ads for this one feature called user-defined functions back in like 1990, I don't know, 4 or something. And then immediately after Informix, which I think was the company that was using those user-defined functions, which was one of the properties of Postgres at the time, as soon as that company like is done with and Oracle is won, Oracle implements user-defined functions. So it was just like this amusing back and forth where marketing departments were getting ahead of engineering departments, and it's just, if you ever read through the history of this, it reads like a murder mystery novel of different companies coming and going. But the original Postgres is all from Berkeley. It was the Ingress project, and then they were making it the Post-Ingress project. It was Dr. Stonebreaker and Eugene, I don't remember the other person.
It's part of the reason why it's pretty code.
Yeah. Well, no, they didn't code it because they weren't coders. They were computer scientists, but they didn't write code. It was all grad students that built it.
I was going to say, typically code coming out of academia is not particularly elegant.
Yeah.
So
the original version, you can go look at it. It's terrible.
It's come a long way.
No offense to all of those amazing people, because honestly, if you go, okay, here's the really cool thing. If you read the 1986 paper on Postgres, you will find things that we are doing today that were envisioned back then. So there was a 1986 paper, and then there was a 1990 paper, which was a follow-up, midway through the implementation. And think about the way that we think about storage now. With RDS, with TimeStream, the new time series database, you have 3 tiers of storage. You have solid-state disks, you have the in-memory, and you have the cold storage. Postgres, as part of their original design, said, hey, people are going to want to store different things in different tiers of storage.
And this is like kind of the theme of the entire show that we've kind of arrived on, which is like, which database do I use? Well, what are your access patterns, right?
Well, Postgres thought of all of it first, is all I'm going to say. And even that idea of separating compute and storage, that was in the original paper in 1990. Do you know how...
That's early.
Yeah, it was like they were really just super far ahead of everyone else. And the downside was the hardware at the time just didn't support the things they wanted to do. So they had this laundry list of features they wanted to include, and they included like 4.
I mean, I can imagine only just like the network itself wouldn't be able to support what they wanted to do.
And I mean, if you think about user-defined functions or triggers and things like that, those are all things that were in the original Postgres paper, and they were things that other databases had talked about, but no one ever got around to doing it. So I'm done. I'm not going to nerd out anymore about Postgres, but it's really cool. Go read the history about it. That's all.
If you're interested in signing up for the preview, I posted the link in chat, so you can sign up for that there.
So yeah, here we get into migration, I guess.
Yeah. So basically, how to migrate today? Like, there's really like only there's a few ways to migrate to Aurora Serverless. Basically, restoring from snapshot, dumping and loading, using DMS, and then restoring from Amazon S3. Those are your 3 ways. Or your four ways. Sorry.
So does the S3 is kind of the way that you would do it cross-region?
That's so you can do a cross-region snapshot restore.
Oh, so you can copy this. Do you have to snapshot the region? Do you have to copy the snapshot from one region to another, or does it?
I believe you don't. I think you can actually just do it cross-region.
Wow, that's great. So that was one of the questions we had from, I think it was Prasuk18 or. Maybe someone else in the chat was asking how they could do that kind of cross-region.
We didn't have that available at launch, so we've added that since launch. So.
Okay, that's really cool. And so we have a couple of questions from Thulaban about how would you downstream data to other services. And so I know that we support Lambda functions as triggers in Aurora MySQL. But do we do that in others as well, or?
We don't support that with serverless today.
Okay.
It's one of the things that we have to take a look at. There are some other technical challenges at VPCs private link endpoints don't allow outbound. Traffic. So right now that's a technical limitation that we've got.
Good point.
Got some more questions also. So PS Riku also asks, anything on the roadmap to support provisioned read replicas backing up a serverless one in order not to wait 30 seconds for wake up for once. A while reads. Okay, sorry, this is tough.
Yeah, I can't read that.
Or their second question, which is much shorter. When will Aurora Serverless support MySQL 5.7?
5.7 is on our roadmap. I can't comment on specific dates, but it's on our roadmap.
Awesome.
And 90% of our roadmap is customer driven.
Yes.
So everything that I've said I've wanted today, if chat could just go ahead and echo that, we'll take that as an actionable piece of feedback to give to your team.
We do. We actually adapt our roadmap quite a bit to customer demand. So based on feedback, we will change our roadmap quite a bit.
I feel like I should quit the company and go be a really big customer for about 5 weeks and then come back just so that I can get the features that I personally want. It's a very selfish way of doing Randall-driven development.
So I think part of that question was also, the first question was around like the 30-second window. If you want to get around that today, the way to do that is to keep capacity 1, and you can turn off pause, so you don't have to keep pause. Turning on or off pause is an option. So if you just have your lowest limit as capacity 1, you'll basically you'll eliminate that wait time or that restore time.
And then you kind of just answered edog124's question there.
So for the reserved instance one?
Yeah, that was kind of the answer. Is you keep that provision capacity of 1 around, and then you turn off pause.
Yeah.
All right.
And then feature-wise, I know you have a slide here on availability across the services.
So, so just comparing like that failover and cross AZ failover and durability. So across the board, Aurora MySQL and to Aurora Serverless, the durability is the same, right? We use the same underlying storage, so you get that same durability across the board. So that's something you don't have to worry about across any of these options. Basically, with Aurora MySQL, you have 3 different options. You have Aurora MySQL with multi-AZ. That's basically having instances that you would have in more than one AZ. So you'd have a read-write node in one AZ, and then a reader endpoint in another one to fail over to. With Aurora MySQL single AZ, you would basically you either would have only a single read-write endpoint, or you'd have both your read-write endpoint and your reader endpoints in the same AZ. With either, and then with Aurora Serverless, we don't give you an option of what AZ to put things in. We just kind of do it for you. With any of these options, like you're going to get failover functionality. The question is like, where is it going to fail over to? With Aurora MySQL multi-AZ, we will fail you over across AZs. With Aurora Serverless for MySQL, we will also fail you over across AZs automatically. The distinction there is fast failover. If an entire AZ goes down with Aurora Serverless for MySQL, what we do is we start pulling from our warm pool. And if we run out of our warm pool, we're somewhat at the mercy of EC2 in terms of when we can replenish that warm pool and get you back up and running. So it could be a little bit longer before your instance is back up. With Aurora MySQL multi-AZ, if the AZ goes down, you'll fail over right away, and you'll basically be up and running very quickly. With the Aurora MySQL single AZ, you have to basically wait until that AZ is back up.
So we have a question from the stream, which is exactly the question I was about to ask. So Sairuku18.
I think it's PS Riku. Maybe, I don't know.
PS
too many consonants right next to each other.
Is asking on the roadmap anything for cross-region, because we support multi-master and multi-region in MySQL now.
Yep.
So
you're talking about like global databases. Side. So global databases is on the roadmap for serverless as well, but it just released. What was it, like November of last year? Right. So it's limited to, I think, Aurora MySQL 5.6 today. Yes. Also. So it's on the roadmap. Yes, it is on the roadmap, but we don't have it in place today.
So I just need you to go ahead and solve all of the problems that I've outlisted. No, thank you so much for
that's my job, right?
Being on the stream. It's been absolutely excellent to have you, and I think the chat is also very thankful, and we'd love to have you back again.
Appreciate it. I'm glad to be here.
Yeah. Are there any other last questions, Nick? Anything else that we need to do? Anything from the email?
We have one email question. It's not particularly on Aurora Serverless, but maybe we can talk about it and see how it applies here. So this email comes in from Doron Lavari. their question is about multi-tenancy. How can they maintain multiple similar to identical schemas or databases in the same database service? They say that they think it's commonly understood how to do this in Aurora and DocumentDB, but they'd be interested to see how it's possible in, for example, Neptune or Dynamo or...
Well, on the Neptune side, you have the advantage of something called RDF, and RDF has universally unique identifiers. So
and what does RDF stand for?
RDF is... It's a great question. What does it stand for?
I'll look it up.
Resource data format. I made that up. Or reference data format. RDF and a query language called Sparkle are one of the ways that you can query graph data within Neptune. And the other way that you can query graph data within Neptune is through Tinkerpop and Gremlin. And the way that RDF works is you have these universally unique schemas that are specified, and so that's part of the query is you pass in the link to the schema. And you also have universally unique identifiers. So each triple, each schema, key, value, and the associated edges are all linked together by these common XML schemas. So if you're absolutely a sadist and you want to work in XML, you can. But just remember, there are other developers who are going to come after you who are going to, look at that code and have to deal with it. No. One of the interesting things about that question about maintaining these schemas, there's a great customer, Siemens Corporate Technology, that uses RDF on Neptune to basically run all of their preventative maintenance for all of these turbines all around the world. Mm-hmm. And they have all these different pieces of information that are coming from like 30 different other data stores. So they have canonical data stores for their manufacturing, for their maintenance, for their ERP, for all these different things. And they bring it all into one place in Neptune so that they can say, okay, well, this was the technician that last worked on it, and this was the time that it was last serviced, and this is when other ones that have had that same technician are failing. This time, it's always human error. And they can go and they can go out and kind of prevent things from happening in a cool fashion. There's a great talk about this from reInvent if anybody's interested. So reInvent 2018 is Dr. Sebastian, I don't remember his last name, but we also spoke about it at the Berlin Summit a couple weeks ago. But yeah, I think that's it.
Yeah, really quickly, I pulled it up and posted it in chat, but RDF stands for the Resource Description Framework. And so you mentioned that these are unique identifiers for the objects and the edges, I assume, also in the graph. And then Sparkle is the query language that you'll be able to use to interact and query those entities in your graph that will be inside of Neptune. So maybe we'll answer that question again in another episode as well for other databases. But I think that's a pretty solid... Oh,
yep, and the stream died, so that's always good to know. Hopefully... Oh, and we're back. And
I think we're good.
I guess if you did miss the end of that question, don't worry. Please send us emails, send us more questions. We'd love to answer these questions for you. This is my job. I mess around with data all day and answer bad questions poorly. But thank you again, Anoop. It's really wonderful to have you on, and I think we'll close out the stream.
Yeah, I think that's about it. Thank you, everyone, for tuning in. Again, questions can be submitted online at databasesdeepdive@amazon.com. I just dropped that in the chat. I'll edit in there a few more times. And so with that, thank you again, Anoop. It's been a great guest, and we'd love to have you back again.
Thanks.
All right. Thanks for tuning in, everyone. We'll see you next week.
Here we go.